Alright, let's look at the homework 16, problem number 4. Alright, so we want to find the work done by this force field in moving object from 1, 0 to 0, 1. Alright, so part A, straight line. Alright, so what we need to do is, so we need to compute, so in order to find work is going to be integral for f. So you have 2xy minus 3 comma x squared, right? Then dot product with dr, which is dx comma dy, right? So which is going to be integral, and over path, let's say path C or something like that. Right, then over the path C, so you have this times that, so you have 2xy minus 3 dx plus x squared dy. Alright, so let's look at part A. So what will be the path? So we're going to do a parameterization, so it's a straight line, so we're going from so here's the y-axis, and then here's the x-axis. Alright, so you're going from 1, 0, so it's going to be right here. And you're going to go from 0, 1, so it's going to be up here. Alright, so it's over here. So going from here to there along a straight line. Alright. So we can parameterize it by x, y is equal to, you're starting from 1, 0, and plus some parameter t times the vector is, you're going to go in that way, -1, and go up 1. Alright, so we can see that we can write it as x is equal to 1 minus t, and y is equal to t, where t is going to go from 0 to 1. Alright, you can check that when it's t equals 0, it's 1, 0. When t equals 1, you're going to get the 0, 1. Alright, so that's part A, and then you're going to have to do the same thing with problem number 3. So I'll let you do that. And B. Alright, so if you want to do a circular arc, so it's you actually go from here and along a circular arc. So let's see, I'm gonna just use a different color. So let's say you're gonna have to go through the circular arc, right? Then the easy one would be, so this is a unit circle, so we can do x equals, say, cosine of t or theta, maybe I should use t, and y equals sine of t, right, where t is going to go from 0 to, right, so it's going to be sine pi over 2, 90 degrees, right, so 0 degree to 90 degrees. Alright, then you can go through the same deal as problem number 3. Alright, part C, lines parallel to axes. Alright, so what you can do is you probably want to do it in 2-step. So you want to do, let's see, so from here to there, you can probably go along the x-axis first. Right, so this is going to be part 1. Then you want to go along the y-axis. Alright, so what you need to do is, let's see, along this path, dy is 0, because there's no change here. So you have integral. Alright, so integral with respect to x, and y is 0. So this guy is 0, and you just have -3 with respect to x. Then x is going from actually 1 back to 0. Alright, so that's a C1 there. And plus, right, then you are going along the y-axis, which means that the x is 0, and there's no change in dx, so this part is 0, and it's actually x is 0 there, so 0 squared dy, you can have 0 squared dy, which is going to be 0, so y is going from 0 to 1, right? But this guy is a 0 anyway, because integrand is 0. So all I have to do is evaluate that. Alright, so I let you compute that. Alright, that's it. That's how you set things up. Alright, I hope that this will get you guys going.